Welcome back to Statistics. In this video we'll be looking at section 1.2, which is going to teach us all about observational studies versus designed experiments. And the objectives in this section are to learn to distinguish between an observational study and an experiment, and to learn about the various types of observational studies. So here we go. Before we get started, let's remember our four-part definition of statistics. Remember, part one is to collect the data in an appropriate way, and that's our focus in the rest of chapter 1. And then in chapter 2 and 3, we'll talk about how to describe the data. But right now, we're just learning how to collect data. So there are two methods of collecting data. The first one is an observational study. In an observational study, data is recorded, but no attempt is made to divide individuals into groups or to apply different treatments. No attempt is made to influence outcome. So an example of an observational study might be to have people fill out a questionnaire. You might ask them, do you consume dairy products? Do you consume fruits and vegetables? You might ask them different questions, but you're not trying to influence how they eat. You're just trying to find out how they eat. So that's an observational study. Then in a designed experiment, researchers divide subjects into groups and apply different treatments to each group, and they collect data, intentionally changing the value of some explanatory variable and recording the value of the response variable. So in a designed experiment, people or subjects, it doesn't have to be people, the subjects are divided into groups, and we control which group each subject goes into, and then we apply different treatment to each group. Where in an observational study we apply no treatment whatsoever. In a designed experiment, we divide people into groups intentionally, or subjects. We divide them into groups intentionally, and we apply some different treatment to each group. So now let's read through this situation together and see if we can decide whether we are looking at an observational study or a designed experiment. So it says, the research team wanted to investigate cancer risk among Danish cell phone users who were followed for up to 21 years. To do so, they kept track of 420,095 people whose first cell phone subscription was between 1982 and 1995. In 2002, they recorded the number of people out of the 420,095 people who had a brain tumor and compared the rate of brain tumors in this group to the rate of brain tumors in the general population. Okay, it says they found no significant difference in the rate of brain tumors between the two groups. The researchers concluded cellular telephone was not associated with increased risk for brain tumors. Well, that's good news. But now we have to ask ourselves, was this a designed experiment or was this an observational study? Well, the answer is based on whether the researchers applied any treatment to the subjects. Did they intentionally place people in one group or the other? Did they intentionally apply a treatment? Did they say to anybody, you must use a cell phone, or you may not use a cell phone, or you can only use a cell phone for a certain amount of time each day? And the answer is no, none of those things happened. So the people in this study were only observed. There was no treatment applied intentionally to them. And so this is an observational study. Okay, now let's look at another example. Another research team examined whether chronic exposure to radio frequency radiation at two common cell phone signals, 835.62 megahertz and 847.74 megahertz, caused brain tumors in rats. The rats in group 1 were exposed to the analog cell phone frequency, the rats in group 2 were exposed to the digital frequency, and the rats in group 3 served as controls and received no radiation. The exposure was done for 4 hours a day, 5 days a week, for 2 years. The rats in all three groups were treated the same, except for the RF exposure. After 505 days of exposure, the researchers reported the following after analyzing the data. We found no statistically significant increases in any tumor type, including brain, liver, lung, or kidney, compared to the control group. Okay, now, in this case, the rats were intentionally chosen and placed in different groups, and different treatments were applied to each group. So this is definitely a designed experiment. In other words, the rats didn't choose which group they belonged to. The researchers chose which group the rats would belong to, and they chose which group would receive which treatment. So this is a designed experiment. The question you may be asking yourself now is, which one of these two methods is better? Is a designed experiment better than an observational study, or the other way around? Well, let's look at some characteristics of each one. An observational study is easier to design than an experiment. Designed experiments must be very carefully designed, and there are a lot of things you have to think about, and which variables you're going to account for and how you're going to set up the groups. We're going to talk about that just a little bit, but you can probably already tell that an observational study is just going to be easier to set up. Also, an observational study is faster, whereas a designed experiment can take a very long time. An observational study might be as quick as a questionnaire, whereas a designed experiment, it's going to take time to apply the treatments to the different groups and follow them long enough to get the results that you need. Okay, an observational study is less expensive, and a designed experiment can be very expensive. And so right now you're probably looking at this and saying, gosh, designed experiments look hard. Why would I ever do a designed experiment? Why not always use an observational study? But the thing is, an observational study cannot determine cause and effect, because there are always going to be things that you have not been able to account for in an observational study, whereas a designed experiment can determine cause and effect. So here is the big payoff for a designed experiment. A designed experiment can determine cause and effect. Okay, now an observational study can be used as an exploratory study to see if a designed experiment is warranted. But an observational study can never tell you that one thing causes another thing. For that, you need a designed experiment. Now here's example 3. This is one of those times when an example doesn't necessarily mean a type of problem that you're expected to work later. This time, we're just getting a situation that we can look at together and just have a way to talk about some of the ideas we still need to talk about. So let's read this together. It says, researchers wanted to determine the long-term benefits of the influenza vaccine on seniors aged 65 and older. The researchers looked at records of over 36,000 seniors for 10 years. The seniors were divided into 2 groups. Group 1 were seniors who chose to get a flu vaccination shot, and Group 2 were seniors who chose not to get a flu vaccination shot. After observing the seniors for 10 years, it was determined that seniors who get flu shots are 27% less likely to be hospitalized for pneumonia or influenza, and 48% less likely to die from pneumonia or influenza. So let's talk about this a little bit. First of all, are the flu shots responsible for the results of the study? Well, when you look at the numbers, let's look back at the numbers. You saw that the seniors who got flu shots were 27% less likely to be hospitalized and 48% less likely to die from pneumonia or flu. So it sounds at first like, oh my gosh, we should make this a law that all seniors have to have flu shots because, gosh, they're so effective. But the thing is, we need to hold on because this is an observational study. So it may not be that the flu shot is responsible for all the results that we saw. Because this was an observational study, the authors were concerned about confounding. Okay, what's confounding? Confounding in a study occurs when the effects of 2 or more explanatory variables are not separated. Therefore, any relation that may exist between an explanatory variable and the response variable may be due to some other variable or variables not accounted for in the study. This problem right here is what makes the difference between an observational study and a designed experiment, because with a designed experiment you're specifically taking action to prevent confounding by applying treatment to different groups. And in an observational study, because you're not applying treatment to different groups, you cannot get rid of this confounding effect. Confounding can be a major problem with observational studies. This is why observational studies cannot determine cause and effect. Often the cause of confounding is a lurking variable. Not always, but sometimes a lurking variable. So what do they mean by lurking variable? A lurking variable is an explanatory variable that was not considered in a study, but that affects the value of the response variable in the study. In addition, lurking variables are typically related to any explanatory variables considered in the study. And then we have a confounding variable, which is an explanatory variable that was considered in a study, whose effect cannot be distinguished from a second explanatory variable in the study. So let me give you a little example of the difference between a lurking variable and a confounding variable, because it's not a big deal, but you may be wondering why we have two terms here. Okay, so suppose we're making a cake, and in my cake recipe I normally put a half cup of oil and 2 eggs, and suppose I bake my cake and it comes out dry, and so I'm going to try again. But when I try again, I change the amount of oil and the amount of eggs, so I increase both of them. And let's also say that my favorite pan that I usually use is not available, so I just grab a glass pan that I don't usually use, but I don't think that much about it. And this time the cake comes out better. Okay, now what caused it to come out better this time? Is it because I increased the amount of oil, or is it because I increased the amount of eggs? Or maybe it takes both of them together to be increased to make the cake better. Or here's something we haven't thought about. Cakes bake differently in a glass pan than they do in any other kind of pan, so maybe the pan had something to do with it. And I didn't even think about that when I grabbed this glass pan. So these two things are confounding variables. I know they probably both had an effect, but I don't know how much of the change was due to which one. And there's no way to tell them apart because I changed them both at the same time. And I didn't even think about the fact that a glass pan could change the outcome. So that is a lurking variable because we didn't think about it. And these two are confounding because we did think about them, but we can't tell them apart. Okay, so that's really the difference between lurking and confounding. Either way, the big problem here is that observational studies do not allow us to claim causation, only association. Now let's think back to the flu shot study that we looked at just a minute ago. Some of the lurking variables that you might say were in that flu study were age, health status, the mobility of the senior. Remember, there were only 2 groups, so we have no idea if the ages are comparable. If it's possible that one group contained more sickly people and the other group contained more people that are generally healthy. It might be that how well somebody gets around determines how well they bounce back from the flu and whether they end up in the hospital. It's entirely possible, in fact, it's even likely, that people who are willing to go get a flu shot on their own also take care of themselves in other ways, like maybe they are more conscious of washing their hands, or maybe they exercise more, maybe they eat better. We don't know. That's why they're lurking variables. It turns out in this case that the way the authors presented their results was they just said that the flu shot is associated with a lower risk of hospitalization or death from flu. They never said it caused it when they published their results, because after all, they were not doing an experiment, they were doing an observational study. Now we're going to talk a little more in detail about types of observational studies. And there are 3 types that we're going to look at. There are more than this that are in use, but these are the 3 major types that we're going to look at together: cross-sectional, case control, and cohort. And I'm going to tell you just basically how each one works and an advantage or 2 of each one. First, we have cross-sectional studies. These are observational studies that collect information about individuals at a specific point in time or over a very short period of time. An advantage of a cross-sectional study is that it's inexpensive and quick to do, but a drawback is that it may not give the whole story. For example, if you were performing a study on the relationship between diet and heart disease, then you might, as a starting place, give a sample of people a questionnaire. And the questionnaire might ask them what their diet is like and, with a few specific questions, and then have you ever experienced heart trouble? And this would be a cross-sectional study because you're just getting a snapshot at this point in time. How are you eating, and do you have heart trouble? And the problem with this is that diet can have, an effect years down the road. So the event that you're studying, which is the heart trouble, might not happen until after the study, and then that wouldn't give you the full picture on the relationship because your study's already over, but the heart trouble happens later. Now let's look at case control studies. These studies are retrospective, which means they require individuals to look back in time, or they require the researcher to look at existing records. And in case control studies, individuals who have certain characteristics are matched to those who do not. So these are also relatively quick and inexpensive. However, people must remember data from the past, which is unreliable. For example, a questionnaire about diet might ask people, over the past 10 years, how many salads per week do you think you have eaten? Well, nobody's going to remember that. And even if you did have a way to estimate it, you would wildly estimate in your favor because we all want to think that we eat right. And, we probably remember what we meant to do more than we remember what we actually did. So if the researchers are not careful in how they set up the study, this kind of thing where people have to remember data from the past can really undermine the whole study. And then our last type of observational study is a cohort study. So a cohort study first identifies a group of individuals to participate in the study, and that group of people is called the cohort. And so, the cohort's going to stay together through the whole study. In other words, you shouldn't have people stepping in and stepping out. It should be the whole group. You follow them from start to finish. The cohort is then observed over a long period of time, and we're talking sometimes years and years here. And over this time period, the characteristics about the individuals are recorded, and because data is collected over time, cohort studies are called prospective. So remember, case control studies were retrospective, meaning they look back to the past, and cohort studies are prospective, meaning they look forward to the future. And these are the most powerful, the cohort studies are the most powerful type of observational study. For that reason, they're also the most expensive because think about the time involved. You might have 10 or 20 years, involved in this, and so it's expensive to run one of these. And the drawback is that people tend to drop out due to the long time frame, and this can, of course, cause problems with the results. An example would be a researcher who wants to do a 10-year study on the effect of low-carb diets. Well, you got to find a group of people who are going to follow the diet meticulously for 10 years. And of course, some people are going to start out doing it, and then for one reason or another, they're not going to be able to finish. Maybe medical reasons, or their priorities change, or, you can't order them to follow the diet for the next 10 years. It has to be something that they do on their own. And so, you're going to lose people, and that is a drawback. Now we're going to look at a few situations together, and we're going to read them and decide if each one is a designed experiment or an observational study. And if it is an observational study, we'll see if we can figure out whether it is a cross-sectional study or a case-control study or a cohort study. So here we go. Researchers wanted to assess the long-term psychological effects on children evacuated during World War II. They obtained a sample of 169 former evacuees and a control group of 43 people who were children during the war but were not evacuated. The subjects' mental states were evaluated using questionnaires. It was determined that the psychological well-being of the individuals was adversely affected by evacuation. Okay, is this an observational study or a designed experiment? Well, the question we need to ask ourselves is, was there any treatment applied? And there was not a treatment applied. In other words, all they did was evaluate their mental state using questionnaires. They did not try to affect their mental state. So this is going to be an observational study. And since it's observational, now we can ask the question, what kind of observational study is it? Well, let's think about how they did this. They obtained a sample of 169 former evacuees and a control group of people who were children during the war but were not evacuated. And the subjects' mental states were evaluated using questionnaires. So these people are remembering back over their whole lives, from the time you were a child until now. How did you feel about this? And how did you feel about that? And how did you cope with this? And have you been divorced? And how did you treat your children? And what kind of relationships do you have? So these things they are remembering from the past. And so this is going to be a case control study. Because remember, in a case control study, people are asked to look back to the past. These are retrospective studies. And also there's always a control group. Remember, we said that people who have certain characteristics are matched with those who do not. And so here we see that this study did include a control group. Now let's look at another situation. Xylitol has proven effective in preventing cavities when included in food or gum. A total of 75 Peruvian children were given milk with and without xylitol and were asked to evaluate the taste of each. Overall, the children preferred the milk flavored with xylitol. So, since the researchers are giving the children the milk, they are applying a treatment to the children. And so this is going to be a designed experiment. And we're going to look at different types of designed experiments when we get over to the end of the chapter in section 1.6. So let's look at another situation. Here we have a total of 974 homeless women in the Los Angeles area were surveyed to determine their level of satisfaction with the health care provided by shelter clinics versus the health care provided by government clinics. The women reported greater quality satisfaction with the shelter and outreach clinics compared to the government clinics. Okay, so is this a designed experiment or an observational study? Well, there's no treatment applied. The women are just surveyed, so this is an observational study. Now, which type? Is this cross-sectional or case-controlled or cohort? Well, they're not looking back to the past and they're not looking forward to the future. So it's not going to be case-controlled or cohort. It's just right now, what is your satisfaction level right now? And so this is going to be a cross-sectional study. Here's another one. The Cancer Prevention Study 2 is funded and conducted by the American Cancer Society. Its goal is to examine the relationship among environmental and lifestyle factors on cancer cases by tracking approximately 1.2 million men and women. Study participants completed an initial study questionnaire in 1982, providing information on a range of lifestyle factors such as diet, alcohol, tobacco use, occupation, medical history, family, cancer history. These data have been examined extensively in relation to cancer mortality. Vital status of study participants is updated biennially. Cause of death has been documented for over 98% of all deaths that have occurred. Mortality follow-up of the CPS2 participants is complete through 2002 and is expected to continue for many years. So, wow, they started studying these people in 1982 and they've been following them all this time. So, first let's ask ourselves, is this a designed experiment or an observational study? Well, the researchers are following the people, they're tracking them and recording their cause of death, but they are not applying any treatment to them. So this is an observational study. And since they started in 1982 and they've continued all these years, this was a prospective study. So what type of observational study is prospective and looks into the future? That would be a cohort study. And you can see the cohort here. The 1.2 million men and women are the cohort, and they are the only people in the study. And so the study follows those people all the rest of their lives, and that's what a cohort is. Now, one last note on this section. You might be saying, gosh, if you wanted to do like a big case control study, where would you get data from the past? Where can we get records to study? How can we get a hold of the data that we need? And you would be amazed that the government already has a wealth of information from the CDC, the Center for Disease Control, the IRS, the GSS, which stands for General Social Survey, and also the U.S. Census, just a wealth of information. And so a lot of times researchers can do like a case control study just based on the records.